Okay, the big idea for today is what is equivalence. It is the idea that we're working on for Chapter 2. A lot of it is going to be solving equations. The I can statements, we have 3 of them. The first one is the most important. I can solve equations with rational coefficients. All right, but it's also important when you're doing your work at home, especially homework. You will have homework this weekend. Sorry about your luck. Is show or explain your work. Okay? And then when we get the laptops, we'll roll those out next week. We'll be talking more about using technology appropriately. Okay? By the end of the lesson, how do you solve an equation that has a rational coefficient? This is the end of the lesson question that I expect you to be able to answer. We have accomplished a lot the last couple of days. Now we're on number 8, learning about solving equations. So you should be on page 112 of your book. And this is the main idea that we're going to be working on.
Tania Green, please report to the office.
So inverse property of multiplication states, all right? Everybody ready to read? Okay, after 2, 1, 2. To solve an equation when the coefficient is a fraction, multiply each side by the multiplicative inverse of the fraction. You guys did very good on multiplicative inverse, okay? So, let's look at the very first example. The very first example is 3/4 C equals 18. There's a couple ways that we can do this. I'm going to show you 2 ways, and you can take your pick. One way is close to what the book says, so if you choose that way, it'll be helpful. You can look back at the book, at the video, whatever, and get help that way. Another way, if you're already used to it, then it'll be helpful to you. We learned about a multiplicative inverse, and we're talking about rational coefficients. So the coefficient in this equation is 3/4, right? It's the number in front of the letter, okay? Or the rational number in front of the variable. All right, we know it's rational because it is a fraction. Very good. We know it's rational because it's written as a fraction. Any rational number can be written as a fraction. So we have a rational coefficient, and we want to get rid of it. We know that we can multiply a fraction by its multiplicative inverse, and it cancels it out. So what am I going to multiply on both sides of this equation? Corbin? 4/3. That is correct. So I'm going to multiply both sides by 4/3, and don't forget that it has to be both sides because we have to keep this equal. Now, this is going to cancel out the 4/3 and the 3/4. It doesn't actually cancel out. What does it equal? 4/3 times 3 of the 4s equals, it equals 1. And so this then actually becomes 1C, or 1 times C, but 1 times C is still just C. All right, so I have C equals, what about on this side? If it helps, turn the 18 into a fraction. How do I multiply fractions together? Corbin? Nope, that's cross multiplication. That's something different. And that's when we do cross multiplication, there's an equal sign in the middle, right? It's 2 fractions that are equal, or 2 ratios. It's called a proportion. But when I've got a multiplication sign between 2 fractions, how do I solve it? Anyone remember?
Don't you divide it?
No, it's called multiplication.
Sometimes you do other ways.
Tristan, what do you think?
Did you ask how you divide them?
No, this means multiplication.
So you go that way.
Very good. Corbin said we go that way, or we go horizontal. We just multiply the numerators times each other, and then multiply the denominators times each other. 18 times 4 is 72. 1 times 3 is 3. So I have 72/3, and then I can simplify that. And if I simplify that, I get 24. So C is equal to 24. And what I love about math is I can check and make sure I did that right. Can I? How do I check? Kind of, okay? What I can do, Madison, what do you think? You can work your way backwards, or I can take what C is and put it back in the original equation. Okay? So now instead of C, I'm going to write 24, and 3/4 times 24 needs to equal 18, which it does. If it does work, I know I found the right answer. Let's say, for example, I found 10 as my answer. Well, 10 times 3/4 is like 7.5, and that does not equal 18, and I would know automatically, Hatton, you screwed up. Try again. But the nice thing is you can do that before you submit your final answer on a test or something like that. Question. How did I get 24? I did 72 divided by 3. Okay? All right. One thing I would like to show you, a little hint. When we're multiplying fractions, we can actually simplify it a little bit. Okay? So this numerator and this denominator, if they have common factors, right, I can simplify it. So I know that 3 goes into both of these, so I can make that 3 1. 3 divided by 3 is 1. 18 divided by 3 is 6. And now 6 times 4 is 24. And 1 times 1 is 1. And 24 over 1 is 1. Okay? So keep that in mind as well. All right? So there you have it. This is how we solve an equation with a rational coefficient. Remember, when the coefficient is a fraction, we multiply both sides by the multiplicative inverse of the fraction. All right, let's do another example. Okay, here's your example. 2/3 A equals 12. In the margin of your textbook somewhere, show me how you would at least set that up. How are we going to write that and attempt to solve it? Go. Okay, I think most of you have probably had a chance to at least write it down and think about it. If we go back to what we said at the very beginning, when our coefficient is a fraction, we multiply each side by the multiplicative inverse of the fraction. So, if I look at this fraction, the multiplicative inverse is 3 over 2. So I'm going to multiply both sides by 3 over 2. And if it helps, you can turn that into 12 over 1. Now I know that these cancel out and create 1, which just leaves me with A. 12 times 3 is 36. 1 times 2 is 2. 36 over 2 is the same as 18. So A equals 18. All right. Yeah. 36 divided by 2 is 18. 18 goes into 36 twice. All right. So besides some minor errors in division or multiplication, do we understand the basic concept? I have a coefficient that's a fraction, multiply both sides by the multiplicative inverse. All right? Now, let's move on to example 2, and it includes the same process with one more step. So let's take a look at example 2. Example 2 in the book is 1.5 S equals 16.5. Now, what is the difference between this example and the first one that we did? Anthony. Okay, Anthony said there's whole numbers with it, and that's correct. So we call these mixed numbers because we got whole and fraction. And what we have to do is we have to eliminate the mixed numbers. Okay? So we want to turn them into improper fractions. All right? And if you recall, the way to do that is, if it helps, you can do like a little multiplication sign there, addition sign there, and we do 2 times 1 is what? 2 plus 1 is 3, and so this is going to be 3 over 2 times S, or 3 halves S. Over here, 2 times 16 and plus 1. So I've got 33 over 2. Now, if you notice, we are exactly where we started with the other problems. Okay? We have a fraction as our coefficient, so I'm going to multiply the fraction by its what? Very good. Say it again. Everybody, one more time. Very good. We're going to multiply by the multiplicative inverse. The multiplicative inverse of 3 over 2 is 2 over 3. Excellent job. I've got to do that on both sides. Remember that these will cancel out and leave S. And now I'm left with 33 times 2, which is 66. 2 times 3, which is 6. That one's fairly obvious. 6 goes into 66 11 times. Now remember, I need to be taking this 11, putting it back into the original problem, and if I multiply 11 times 1.5, I should get 16.5, which I do. All right, one more example, and then I'll let you guys start working. All right, sorry, go ahead. Copy that down, and then we'll do one more example. Are there any questions at this point? So far, so good. All right, let's do one more example. All right, here's our second example. We have 2 and 1/4 B equals 18. What is the first thing I have to do in this problem? Tell your neighbor, what's the first thing you have to do in this problem? Okay, somebody from this table, let me know. What is the first thing I'm going to have to do? The other 2 tables need to pay attention as well. Okay, we do want to multiply each side by the multiplicative inverse, but the problem is I have a mixed number. So what am I going to do first, Trevor? Well, we can set the 2 to the side if I'm trying to convert the fraction to a decimal. But right now I need to use the whole mixed number. So what do you think I'm going to do, Madison? I'm going to take 2 1/4 and change it into an improper fraction. Excellent job, Madison. So once again, I do that by remembering to multiply here and add here. 4 times 2 is what? 9. No, it's not. 4 times 2 is 8 plus 1. 9. So I'm going to have 9 over 4 times B equals 18. Now we can go back and do what my Sean said, which is to multiply both sides by the multiplicative inverse. The multiplicative inverse of 9 over 4 is 4 over 9, correct? So I'll multiply by 4 over 9, 4 over 9. And I can eliminate these two fractions because we know any fraction multiplied by its multiplicative inverse equals 1. 1 times b is simply b. Now, this is one where simplifying might come in handy. All right, if I know that 9 and 18 have a common factor of 9, 9 divided by 9 is 1, 18 divided by 9 is 2. Now I can do 2 times 4, which is 8, 1 times 1, which is 1, b equals 8, okay? And then once again, if I throw this back in to here, I know that 8 times 2 and a fourth should equal 18, which it does. 8 times 2 is 16. 1/4 of 8 is 2. 16 plus 2 does equal 18. So we're good. Are there any questions? All right, we are going to work on the got it problems. At the bottom of the first page, 112, I want you to work on problems B as in beach ball and D as in dog. So I want B and I want D. And then on the next page, page 113, I want you to work on got it F. Okay, you should have had an opportunity to work on the 3 got it problems that I assigned B, D, and F. So let's go over those quickly together. B was -2 over 9 times D, and that equals 4. Once again, we're going to multiply both sides by the multiplicative inverse. The multiplicative inverse of -2 over 9 is what? What kind of 9 over 2? Very important, right? So -9 over 2 times that, and then we also have to do that on the other side. Okay, and we can make this a fraction if it helps. Now, I know that -9 over 2 times -2 over 9 is going to equal 1 and essentially cancel each other out. I'm left with a D. Over here, I've got 4 times -9, which is -36, over 1 times 2, which is 2. So I know that D equals -18. Okay? Does that make sense now that you've seen it?
It makes sense. It makes it better.
Okay, that's what we're looking for. We're looking for making it better. All right, let's do another one. Let's do D. Here we go. D was -24 equals -6 over 7P. Oh, put the P in the wrong place.
I'm about to cry.
All right. Now, sometimes this really messes people up. They're like, wait a minute. You can't put the coefficient on the other side?
Yeah, you can.
But yeah, you can. It's no big deal. Hatcher, you have a question?
No, I switched them around.
All right, very good. If you want to, you can do like Hatcher did and just switch them sides. Okay? All right? So, now what is my coefficient, first of all? Who can tell me what my coefficient is? Cedric. -6 over 7 is in front of the P, right? So that's my coefficient. What is the multiplicative inverse of that? Stephanie. Very good, -7 over 6. So I'm going to multiply -7 over 6 on this side and on this side. Okay?
Why would we change the negative sign when it's with the 6?
You don't change the negative sign.
If you flipped it to the 7.
It doesn't really matter.
It's in the middle.
It's out in front. The negative sign is out in front of the fraction. It doesn't really matter where you apply it to the numerator, denominator. It'll work out the same. Okay, good question. All right, now let's do these last figures. I know that this -6, 7 and this -7 over 6 is canceling out and leaving me with P. I'm going to do a little simplifying right off the bat here because I can see that 6 and 24 have a common factor of 6. I'm going to change that to 1, and I'm going to change this to what? 4. So now I multiply. 1 times 1 is 1. 4 times -7 is -28. So -28 over 1 is the same as -28. So -28 equals P, or P equals -28. Although I did it wrong. What mistake did I make?
You put the 28.
Who can find my mistake? I just realized I screwed up. Cedric. No, I did. But what mistake did I make?
You didn't put the negative sign.
Okay, I made a mistake with the negative sign, right? Because look, this is negative times a negative, which should be a positive. So this should be positive 28. All right? Good job. All right, last one, F. F is 1 and, let me write that again. 1 and 7/8 times y equals 4.5. Okay, remember, the only difference is we've got mixed numbers as a coefficient instead of a fraction or an improper fraction. So we're going to change this to an improper fraction. What's 8 times 1? plus 7? No, 15. So 15 over 8 times y equals, what's 2 times 4? What's 8 plus 1? And I've got 9 over 2. Okay? Now we're back to the very beginning. The same thing we've done in all the other problems. I multiply by the... Everybody say multiplicative inverse. All right, so the multiplicative inverse of 15 over 8 is? Very good. And I have to multiply on both sides. Okay? So we know that this is going to cancel each other out, and I'm left with y. I'm going to do, let's see, I can probably simplify a lot, right? I can make that 1 and make that 4, right? And I can make this, 3 and make this 5, right? So 3 times 4 is 12. 1 times 5 is 5. So y equals 12 over 5. Or, what's another way I can write that? If I divide this, 5 goes into 12 how many times? 2 times. With 2 left over. So, our answer for that one is 2 2/5. Okay? All right, we have one more thing to learn about. And then you guys will have a chance to work on some homework so that you don't have to do it over the weekend. All right? Everybody take a look at example 3. Example 3 on page 113. Okay. Example 3 is a little bit different. Look at example 3. What do you notice is different about example 3 than the other 2 examples? Tell your neighbor. Okay, Robert, you had your hand up. What's the difference with example 3? What's a decimal? Say it again. Yeah, what's that number called? The number in front of the variable is called a what? All right, so the mathematical way to say that, Robert, is the coefficient is a decimal. Well, that's handy because read this with me, and we're going to figure out how to solve that. After 2, 1, 2. To solve an equation with a decimal coefficient, divide each side of the equation by the coefficient. All right, so that's pretty straightforward, right? So if I have 3.15 equals 0.45n, what is my coefficient in this problem?
3.15.
Nope. 0.45n. The 0.45 is in front of the variable, and that is my coefficient. What did it say to do? Divide each side of the equation by the coefficient. So I'm going to divide this side by 0.45. That's going to cancel out. Divide the other side by the same thing. So this cancels, and I'm left with n. Now I just have to do 3.15 divided by 0.45, and that just happens to be 7. And once again, we can double check that by taking the 7 and putting it back in the original equation. All right, let's do one more example, and then I'll let you guys get started. Here's the example right here. I have 10.8 equals 0.9n. What is my coefficient in this problem? Lay. 0.9 is correct. Good job, Lay. So remember what it said to do. Divide each side of the equation by the coefficient. So I'm going to divide by 0.9, divide by 0.9. I'm left with n on this side, and 10.8 divided by 0.9 is what? Anybody remember? It is 12. Okay? So n equals 12. Once again, I should probably take that 12, enter it back into the original problem, and 12 times 0.9 should equal 10.8. Okay? I will allow you to use calculators if you would like to. Okay? And what you are going to do is work on the got it's. Let's see. I think I would like you to do, actually just do all of those, okay? G, H, and I. Now, quick review. If you look on the margins of that page, it gives you a quick review. We've been doing long division. I's here. We've been doing long division. Now they're showing what do you do when you're working with decimals, right? Well, you make sure that the number out front, you want to move the decimal all the way to the after the last digit, okay? However many spaces you move it here, you move it there as well, and then you can just simply do long division like we have been the last several days. That's how I would prefer for you to do it, all right? But if you're really struggling, grab a calculator. Are there any questions? Okay, go ahead and work on the got it at the bottom of page 113. Got it's G, H, and I. No, you're going to do it right now.